Hello everyone, this is Mr. Appel, and today I'm going to do a quick little review of trigonometry, everything you need to know about trigonometry that you've learned so far. So let's start with a pretty straightforward problem, which is a right triangle, and we only know one of the three side lengths. So I know this is trigonometry. I know I have to use trig here because I go through the other options. It's not Pythagorean theorem, because yes, it's a right triangle, but I'm missing two of the three side lengths. So Pythagorean theorem only works when you know two of the three already. So that's not going to help. Okay. It's not a special right triangle. It's not a 30-60-90. It's 35. So it's not that. So what's left? Trig. So let's start with writing a trig equation. And I've got two different unknowns I'm trying to solve for here, x and y. I'll go alphabetically and start with x, although it really doesn't matter. So x is what I'm trying to find, and I need to match up one angle with two sides. So I'm going to take the angle that I know, match it up with the side that I am interested in, and a side that I know. Remember, one angle, two sides for your trig equation. And now I have to determine which trig equation to use. Well, which one is going to connect? Let's see what they are. Y is the hypotenuse. I know that because it's opposite the right angle, so I don't want that. I've got the opposite leg and the adjacent leg. And you should know from SOHCAHTOA that the tangent is the ratio to use there. And so the tangent of 35 degrees should be equal to the opposite leg, so x is opposite the 35-degree angle, over 25, which is the adjacent leg. So write your trig equation and then use algebra to solve it. So how do we solve that? We want to get x by itself. This is just basic algebra 1 here. X divided by 25, so we're going to multiply both sides by 25 to cancel that out. And so we get 25 times the tangent of 35. And now we're just going to plug that in our calculator. And if you show this work, but make a mistake with your calculator, you're going to get most of the credit for the problem. So you need to show that work. You need to show where your answer that you're putting in the calculator comes from. So now let's put that in the calculator. So for this one, this calculator, you have to do it a little differently. Make sure you know how to use the calculator you're using. So 25 times the tangent of 35, so I have to do 35 and then the tangent of that. So that's the tangent of 35 and then equals. Now I didn't tell you in this problem what to round to, so I'll tell you that now. Let's say round to the nearest hundredth. The instructions on your quiz will tell you what to round to, so I'm telling you that now. So round to the nearest hundredth, so 17.505 rounds to 0.51, so 17.51. So x is 17.51. Should probably write that with one of my favorite math symbols, the approximately equal to. Right? It's not equal to, it's kind of equal to. And that's that. All right. Now we want to solve for y. And we're going to treat this really like a totally new problem. So let's just get rid of all that and start over. Whoopsie. Made a little mess there, sorry. Okay. So now to find y, again, I want to write another trig equation. I'm going to connect an angle, side that I want, side that I know. Notice I'm not using the x, even though I did figure out what that was in the last problem just a moment ago, because my answer was rounded. And so I don't want to use x, and I also don't want to use Pythagorean theorem now that I know x, because again, I'm using a rounded answer. You can do it, and you could use your calculator to get there and get the same answer, but I don't recommend it. Better to write a new trig equation. So what's the trig equation that connects the 35 degrees to the side that I know and the side that I want? Well, where are they? Y is the hypotenuse. 25 is the leg that's next to the 35, that's adjacent. So adjacent hypotenuse, that's cosine. So my trig equation will look like this. The cosine of 35 degrees is equal to the adjacent leg over the hypotenuse. Now to solve that for y, got to do a little bit of work. We have to multiply both sides of the equation by y. So I have y cosine of 35 is equal to 25. And now I'm going to divide by the cosine of 35 degrees on both sides, which looks a little weird, but that's just a number. So that over that cancels, and I'm left with 25 over cosine of 35. And again, I should see this on your paper before you go to your calculator. Once you've got that, let's go ahead and do it. So it's 25 divided by the cosine of 35, and that equals, rounded to the nearest hundredth, 30.52. So y is 30.52. Did I do that right? Yes, 30.52. Okay, that's that. Moving on. Now here is a different problem. Sorry, just checking the time. Here's another problem. What's different about this one is instead of finding one of the side lengths, the angle is what we're trying to find. Okay, so I'm still writing a trig equation that connects the angle, and this time the angle that I want, with the two sides that I know. And which trig equation, which trig function will connect this angle with this side and this side? Well, 5 is the hypotenuse, and 2 is the leg that's adjacent to the x. So adjacent to hypotenuse is cosine. So the cosine of x is equal to the adjacent over the hypotenuse. Well, how do you solve that? Well, we're not taking the cosine of an angle, we're doing the opposite. We're saying the cosine of what angle equals this. So it's the inverse cosine. The way we write that algebraically is that x is equal to the angle whose cosine is 2/5, or the inverse cosine of 2/5, and that's how you read that. Again, I should see this equation written down before you go to your calculator, but once you've got that, oops, that's what you're going to type into your calculator. Okay, so I'm going to go to the calculator, and I'm going to do the inverse cosine. Again, make sure you know how to do this on your calculator. Ask me if you're not sure. So the inverse cosine of 2/5. So 2/5 is 0.4. The inverse cosine, and I see it's 66.4. And with angles, I usually round to the nearest degree. So let's round that to the nearest degree, which is 66 degrees. So x is 66 degrees. And that's how you do an inverse